In this video, we will continue solving another geometry question taken from the blog post 20 questions of maddening delicious geometry. Again, I like to emphasize that I'm not the author of these incredibly interesting problems, but I'm merely posting my solutions on YouTube. I will encourage you to visit the blog yourself, and the link will be posted in the description. So, this problem is titled Semicircle Terjacent. We have a triangle subtended by the semicircle. A circle is inscribed in the triangle, but the circle itself has another triangle inscribed within it. There seems to be quite a lot of things going on altogether. So let's take a step-by-step approach, find some angles around the diagram, and draw some additional lines as we see fit. The first angle we can label in the diagram is that of the triangle. If you don't know already, any triangle subtended by a semicircle must be a right angle triangle. What do we mean by subtended? Well, it means that the 2 points of the triangle are fixed at the two ends of the diameter of the circle, and the third point can be at any point of the circumference. After putting in this label, there is another well-known fact that we can put to good use. We call a line the tangent to the circle if it touches the circle only at one point. It is well known that if we drop the radius from the center of the circle to the point where the tangent touches the circle, we will always get a right angle. Using this fact, we can draw in a few additional lines and put a few more angles onto our diagram. With 3 right angles in the quadrilateral, we can conclude that the final angle must be a right angle as well, since angles in the quadrilateral add up to 360 degrees. With this, we are almost done. I am going to introduce a final fact which will be required to solve the question. The angle subtended by the arc at the center of the circle is always twice the angle subtended by the arc at the circumference. That seems like a mouthful, so let us illustrate using diagrams. If the angle at the center is 2a, then for the same arc, no matter which sector you pick, as long as you are subtending the arc from the circumference, it is always half the measure of what you get at the center. So in this case, we get a as a measure of the angle at the circumference. Knowing this, it's now trivial to see that the angle we want to find is 45 degrees, obtained by halving the right angle at the center of the circle. Looking back at the question, while it seems not to be too tough at all, the lesson of the story is that it pays to draw certain lines on the diagrams if they help provide useful information. Although, sometimes this is a balancing act, as drawing too many lines might clutter up your diagram, making it harder to solve a question. As you solve more and more geometry problems, your intuition about picking the correct lines to draw will grow stronger over time, and this is more of an art than exact science. We have come to the end of the video. I hope you have enjoyed the video, and I will see all of you in the next one.